Hello, this is David, and previously we saw that for a number of reasons, one being that it's just difficult to extract a single line item adjustment rate. It's, whether it's a swimming pool where you might do surveys and interviews, you might run a regression analysis, you might try paired sales. It's difficult to get a good number. The other problem they found for appraisers is that even if you kind of get a number, you're probably working in a range. In other words, a swimming pool is probably a range, not a single number. It's not going to be necessarily 18,000 exactly, and the gross living area may not be exactly $90. It may be a range that it comes in. So we thought about, is it possible that residual analysis could help the appraiser to kind of gauge how they're doing when they get that? Maybe they're putting stuff in too high at the end of the range or low, or they just got one wrong. So that leads to the next question. Could a residual analysis just be used to help us get the adjustment rates in the first place? In other words, instead of where you extract the pool by itself, that would kind of be a from the bottom up. We might use the residuals that are based on your model and the sales prices kind of from a top down. And so that's what we're looking at now. We're in a spreadsheet that's actually an application that is in process, and I'm going to build a hypothetical market here. For gross living area, I've used $100, basement finished 50, basement unfinished 25, the garage is 10, the pool is 20, location 10% on a rating of 1 to 3, and 5% per year appreciation rate. And then we're going to scramble it plus or minus 10%. And I did find out the F9 does not lock up the, where it does Camtasia Recorder, it does not freeze the one I'm using now, the Snagit. So I'm going to click here a few times, and now we've got some data, and that's the 10 sales up here, and we're going to transfer them. All right, now the first thing that you're probably going to ask, and we can think about just a minute, is how in the heck do you get a residual out of a adjustment grid? Because a residual is the sales price minus the predicted price from the model. And when we use a sales grid, we're not really using, we don't really get a predicted sales price from the model. We get an adjusted sales price, which has no relationship to the sales price of the comp. So how do we get that? Well, what I did is I set up a basic adjustment grid, and you can't see them here. They're sheets that are hidden. And then in that, I've added for an adjustment grid for each comparable. So I call those shadow grids. So if there's 10 comparables, which we have here, there's 10 shadow grids, so there's 11 grids altogether. And the shadow grid for comp 1 becomes the subject property for that grid. Then I know what it sold for, and I know what the adjustments indicate its value is. So I actually get an adjusted, or not an adjusted sales price, I also actually get a predicted sales price. I think I use the average of the adjusted sales prices for the other 9 comparables. So we can get residuals. Now the question that we have in this is, can residuals be better than what the appraiser does? Well, this isn't really fair because we know the answers. For example, let's put the answers in. It's $100, $50, $25, $10,000. The pool was $20,000. And the location was 10%, and the day sent sale was 5%. The ones in red means there were no difference to adjust for. Sometimes in an adjustment grid, you may only everything in red but one. So we have these. Now I can click use my input. And by the way, the adjustments are the same here because these are new houses. I didn't want to get into condition. And we then got this first number is the MAPE, and the second number is the average deviation, just like we've been doing in the book. And I'm going to write these down. Let me get my keyboard out of the way. Let me write these numbers down. 5.4 and 3.5, and those are pretty good numbers if that was real world data, and that's the sales prices were randomized by 10%. And the question we have is, if that is the residuals here, because it's mixed up plus or minus 10%, could we possibly do better than the actual virtual coefficients that we use to build the model? Now, my first inclination would be no. You're not going to do better than that, and I can promise you that when an appraiser goes out and digs up these adjustment rates, they're not going to be near as close as what a model is going to return if you use the virtual coefficients, even if it's plus or minus 10%. So this is like way better probably here than what an appraiser's ever going to be able to pull up on adjustments one by one. So the question is, can we beat that? Now, I'm going to run the day since sale here, and it's going to try to calculate it in a different way. And these are methods that we saw before on our I think it's in the, you maybe haven't gotten to it yet, in the chapter on methods, and we have a chart of the different methods and we talk about the different methods. This is one of the methods here. This is the slope of the residuals. This chart B, this is the residual. This is a chart based on the residual analysis, probably more like on these two. And then this in yellow is what we just ran. This 11% that we got here, this is a cumulative paired sale. So those are some different ways that I've mixed all up. But the point is, I did make a change and it looked, and this is what our residuals were a minute ago. And don't worry about this last one. This is still this workbook is a work in process, this template, and I'm going to change what that is. But it was 5.4 and the spread was 3.5. We know better, lower is better. So this is actually better. This minus 4% actually gives better residuals than the actual number of a of plus 5. So now let's take a look here. Here it got even better. Now we're to 3.2%, 3.5%. We were 5.4%. So with just these two, we can see that the residuals can actually give a better answer than the actual virtual coefficients when the data is, randomly has random variance in it. In this case, it was plus or minus 10%. So we can see it gets better. So on a hypothesis basis, there was a, if we had set a hypothesis that using the virtual coefficients will give a better answer than the residuals, than going by residuals, then the answer would probably be false, or it would be false because we proved it one time. Now, we didn't get that much better using residuals. We started out at 5.4 and we ended up at 3.2, and these were the same 3.5. But keep in mind, I don't think the appraisers, if an appraiser tried to go out in a real market, they wouldn't be anywhere near this good. So the residual analysis would probably be way better than when the appraiser extracts each individual adjustment. When he or she extracts those independently and in those ranges, how they apply them, they're going to be way lower than this. So it looks to me like residuals could help appraisers make adjustments better than simply going out and digging up the adjustment rates. And that's under the, under the qualification. That's when you have a lot of data to use. So in some markets, obviously, you're not going to use any mathematical. You're certainly not going to use this. Thank you.